This is a solution to problem number 12 from semester 1, review number 6. Here we're asked to simplify a sixth root, and we have the sixth root of a quotient. So as the first step, I'm going to rewrite it as the sixth root of the numerator. So the sixth root of x to the second, over the sixth root of 9y to the fourth. And it's going to be a little easier to simplify if I rewrite 9 as 3 squared. So I'm going to do that. So I have the sixth root of x squared over the sixth root of 3 squared y to the fourth. The issue that we have here is that we have a radical in the denominator. So we're going to have to rationalize the denominator, and we need to multiply by a funny form of 1. And since we have a sixth root, we're going to need 6 of each of the factors that appear in the denominator. So for 3, we have 2 3's, right? So in order to get rid of the radical in the denominator, we're going to end up needing 6 3's. So I'm going to multiply this by the sixth root of 3 to the fourth, and I'm going to put the same term up in the numerator. When I look at the next factor that we have, which is y to the fourth, we have 4 y's, meaning we need another 2 y's to get to 6 y's. So I'm going to multiply by the sixth root of y squared over the sixth root of y squared. Now in the numerator, we're going to multiply across, so we're going to have the sixth root of x squared 3 to the fourth y squared. And in the denominator, we're actually going to have the sixth root of 3 to the sixth y to the sixth. All right, so I'll write that out. So we have the sixth root of 3 to the sixth, because 2 plus 4 is 6, and sixth root of y to the sixth, which was our goal here, right, in order to rationalize the denominator. So in the numerator, we're going to have the sixth root of x squared 3 to the fourth y squared. And the denominator, the radical's now eliminated, which is what we wanted. So when I pull the sixth root of 3 to the sixth, 3 comes out. And the sixth root of y to the sixth would be the absolute value of y. And now for the numerator, the answer actually shows this in a little bit simplified form. So I'm going to simplify this further. I'm going to rewrite this as, first I'll put it in rational exponent form and then back into nth root. So this can be thought of as x, the numerator can be thought of as x to the 2/6 3, let me undo that, 3 to the 4/6 and y to the 2/6 over 3 times the absolute value of y. 2/6 is the same thing as 1/3, so x to the 1/3, 4/6 is the same thing as 2/3, y to the 1/3, all over 3 times the absolute value of y. And then I'm going to rewrite this all as a cube root in the numerator. So I have the cube root of x times the cube root of 3 squared times the cube root of y all over 3 times the absolute value of y. And I should rewrite 3 squared as 9. So I have the cube root of 9xy over 3 times the absolute value of y. I think the answer key just has y, not the absolute value of y, and that would be assuming that y is positive.